So density is a really important topic. It's actually going to be really useful when we get to solutions and allowing us to change from one unit to another. But density is the amount of matter, or how much stuff, is in a given amount of space. So when we're talking about the formula for density, density is represented by the letter D. Density is equal to mass, the amount of matter, in a given amount of space per volume. So density, D, is equal to m over v. And if you look at the table below, the table actually gives you a bunch of density values for different substances. Now the reason that it can do that is density is called an intensive property. Now what it means for something to be an intensive property is it does not depend with a D, on the amount of stuff. Okay? So what that means is if, for example, I have gold. If I have 1 gram of gold or 100 grams of gold, as long as it's at 20 degrees Celsius, the density is going to be 19.32 grams per centimeters cubed. If I have pure water, so not tap water, but pure water at 20 degrees Celsius, doesn't matter if I've got a cup full or a lake full, it's always going to be 0.9982 grams per centimeters cubed. Because it's intensive, it does not depend on how much. Now, on the other hand, things like mass and volume are extensive properties. And what that means is that they do depend on the amount of stuff. So as I have more gold, the mass gets larger. As I have more gold, the volume gets larger. So intensive, density is always the same for gold. Extensive, the more I have, the larger it gets. Okay? Now, when we talk about matter, remember, matter is anything that has mass and takes up space. So it has to have mass and volume, okay? There are 2 big categories of matter. We can talk about pure substances and we can talk about mixtures. Now, a pure substance has constant composition, so it's always the same, okay? So we can have elements, which are the simplest form of matter. And the easiest way to recognize an element is element symbols or capital letters. It can only have 1 capital letter. Now it can have lowercase letters as well. For example, iron is Fe, but I've only got 1 capital letter for my element. I could have H2. I've got 2 of them, but it's only 1 capital letter. I could have Mg, again, only 1 capital letter. Compounds are 2 or more elements, and it's important that you know they are chemically combined. So for example, H2 is an element, H2O is a compound, okay? Mixtures are 2 or more substances that are physically combined. Now the difference between chemically combined and physically combined, chemically makes something new. So when I combine hydrogen and oxygen to make water, I'm taking 2 different gases, I'm combining them, I'm making this new completely different compound that has new colors and textures and density and everything about it is different. When I make a mixture, I'm physically combining two things. And when I physically combine, for example, salt and water, I have salty water. It's not anything different, okay? I've got two types of mixtures. I can have homogeneous or heterogeneous. The prefix homo means that they are the same throughout. So when I look at a homogeneous mixture, the top of my mixture looks the same as the middle, looks the same as the bottom. The density is the same on the top, on the middle, on the bottom. The color, the texture, everything about it is the same all the way throughout, okay? The term that we use for homogeneous mixtures most of the time in chemistry is solution, okay? A heterogeneous mixture, on the other hand, is going to be hetero or different. So it's going to have different textures or different colors or different shapes in the top versus the bottom. So the easiest way to think about a heterogeneous mixture is a salad. If I make a salad, if I look at a salad, I can tell the difference between the lettuce and the cucumbers and the tomatoes and everything that goes in the salad. When I stir them up, it doesn't suddenly all look the same. I can still tell what's in the salad. Versus a homogeneous mixture, if I take salt and water and stir them up, I can't tell where the salt is, I can't tell where the water is, it all looks the same, okay? So they've got this nice little table at the bottom, and the table breaks down all of our different parts of matter. So again, remember, we've got matter, which is heterogeneous or homogeneous mixtures.
Hey, Laura.
We can have pure substances, which are elements or compounds. And elements are made up of atoms, protons, neutrons, electrons, which we will talk about in a later chapter.